All right. So now, what if conditions aren't changing? What if we don't have a P1 V1 and a P2 V2? What if we just want to find temperature or volume or pressure? And what we're going to do is we are going to find a value for R. So we're going to take this equation, V is equal to R times NT over P, which we had on the previous page, and we're going to rewrite it as PV equals nRT. And PV equals nRT is called the ideal gas law. Now, this is ideal because this is assuming that gases are behaving properly, meaning that every collision they have is a perfectly elastic collision, meaning they just bounce off each other and they mix well and occupy their own space and all of the things. Okay, so they're acting in an ideal way. What we're going to look at is the relationship between pressure, volume, moles, temperature, and this universal gas constant. Now, when you're using this ideal gas law, you have to be in atmospheres, liters, moles, and kelvins. There is no option for any other units. And what we do is, or what they did is they found the value of R. So they found the constant when everything was at a standard temperature and pressure. So that is a temperature of 273.15, atmospheric pressure of 1, and then 1 mole of gas occupying 22.4 liters. Okay, so this is at standard temperature and pressure. These are just givens. So anytime they tell you, hey, you're at standard temperature and pressure, you're like, okay, temperature is 273.15, pressure is 1 atmosphere. Then the volume is depending upon how many moles you have. So if they tell you that you have 1.4 moles, it's not going to occupy 22.4 liters. But if you have 1 mole of any gas, it always occupies a volume of 22.4 liters. Anyway, what they then did to find R was they took the equation R equals PV over NT, and they subbed in pressure as 1. Volume, they used a more accurate value of 22.414. Moles, they put in 1 mole, and then temperature at 273.15. And if you calculate this out, it comes out to 0.08206 liters atmosphere per mole Kelvin. This is not something you have to memorize. This is on your information booklet. They give you the value for R. I should double check that. Yes, it is. So there it is. Universal gas constant. R is equal to 0.08206. And be careful. Sometimes you'll look at different data and someone will use 0.0821, right? So different people use differing precisions of different values, but we're going to use the 0.08206 in our calculations. Now, you can use the ideal gas law when the number of moles is involved or is changing, because often we won't use the P1 V1 over T1 calculation. Or, most importantly, if you need to solve for a variable and you know the other 3. So the rule with an equation is that you can just have one unknown. So if I know pressure and I know volume and I know moles, then I'm also given R, so I could solve for temperature. Let's give this a go. This says, what is the volume of a container? So volume is my unknown, of 1.4 moles. So my N value is 1.4 moles of hydrogen gas. So we know this is going to be a gas at standard temperature and pressure. So right away, I know my temperature is 273.15 and that my pressure is going to be 1 atmosphere. And like I said, you can use this formula if you know 3 pieces of information and you need to find the 4th, because the R is always given. So the formula is PV equals nRT, and we're going to use this to solve for V. So we're going to do nRT divided by P. And in for the N, we're going to put 1.4. In for the R, we're going to put 0.08206. In for the temperature, we're going to put 273.15. And then in for the pressure, we're going to put 1 atmosphere. And when we say 1 atmosphere, that's not 1 sig fig. That is a precise value, so we wouldn't take it into consideration. So when I'm typing this into my calculator, I'm going to do 1.4 times 0.08206. You can even store that as something in your calculator. I was like, ooh, if I had an R, that would be great. Then you have to type it again and again. And then times that by 273.15. Divide by 1 won't make a difference. And I will get a volume of 31, rounded to 2 sig figs, liters. Awesome. Try the next one. So this one, my volume is 10 liters. My pressure is 0.950 atmospheres. My temperature is 300 kelvins, and we want to know the N. So we're going to use the formula PV is equal to nRT. This time we're going to solve for N, so we're going to divide both sides by RT and get PV divided by RT. In for P, I'm going to put 0.950. In for volume, I'm going to put 10 liters. In for R, I'm going to put 0.08206. And in for temperature, I'm going to put 300 kelvins. Now that 300 kelvins is only 1 sig fig, so I'm going to give 1 sig fig in my answer. And I get 0.95 times 10 divided by 0.08206 divided by 300. And that is going to give me 0.4 moles of my gas. All right, so hopefully that made sense. And then we will come back and start using this in some stoichiometry.